So when we're finding the greatest and least values of a function, obviously it has to be bounded, our function. Otherwise, because in most cases they kind of just go forever, and so you can't really find the greatest and least values of this, because the greatest value is going to be up here somewhere, the least value is going to be down here, it's going to be infinity and all sorts of foolishness. So we are only finding the greatest and least values on a bounded curve. In order to find the greatest and least values, when you have a curve like this one, 9x squared plus 2, that's going to look, you know, like this or something. Not exactly like that. So your greatest and least values are going to be one of two types of point. So it's either going to be the maximum or the minimum value, or it's going to be the points on the boundary. So the only thing we need to find are our maximum and minimum values and our boundary points. We have already gone through how to find the stationary points which give us the maximums and minimums. I'm going to go through that for this question again anyway, just to give you a refresher because I know we hated it. And then we're also going to look at how to equate the boundary points in this case as well. So when we're finding our stationary points, the first thing we do with our function is to derive it. So if f of x is equal to 9x squared plus 2, f dash x is going to be 2 times 9, which is 18, x, and then 2 take 1 is 1, so it just stays as 18x. That 2 disappears because there's no x value tied to it, so bye-bye. That's our derived value. When we're finding our stationary points, we then have to set that equal to 0. So 0 equals 18x. We want to get x by itself. Divide it by 18. That tells us that x is equal to 0. So that is either a maximum or a minimum at x equals 0. Remember then, we have to take points either side. So when x equals -1, f dash -1 is equal to 18 times -1 is equal to -18, so that's down. So this is probably going to be a minimum point. When x equals +1, f dash 1 equals 18 times 1 equals 18. Oh, who'd have thought? That goes up. This is a minimum point. So our least value could be this, or it could be, actually no, in this case it's pretty much just going to be this. So we already know what the least value is, now we need to know what the greatest value is, and that's where these boundary points come into it. So, to find the boundary point, essentially what you need to do is just put both of the boundary points, so x is -3 and x is 3, sub that into the original equation, figure it out, and that will tell you what your y value is, which will tell you the coordinates of that point. So when x equals -3, f of, not x because we're giving it a number, f of -3 equals 9, -3 squared plus 2 equals 9 times 9 plus 2 equals 81 plus 2 equals 83. So we've got a point there at -3, positive 83. And then when x equals +3, f of 3 equals 9 times 3 squared plus 2 equals 9 times 9 plus 2 equals 81 plus 2 equals 83. Hey, look at that. They're the same though. So there's going to be a point there at +3, 83. So what that tells us, and we can pretty much figure that out from here anyway, because our minimum value is at 0, this means that this curve is centered on the y-axis, which means that if we've got 3 this way and 3 that way, it's going to be a really symmetrical curve, which means that it's just going to look like this. So our greatest value that this curve reaches on this interval is 83, because the greatest value, we're looking at our y-axis. So don't know if you can see this at the bottom of the screen. Be a bit bum if you can't. Greatest is 83, and our least, which we already figured out, is what is it though? Oh, we didn't actually figure that out, did we? That's foolish of me. So remember, we needed to have sub this back into our original equation, which is something that I didn't do, so I'm very sorry about that. So x is 0, pop that back into here. So f of 0 equals 9 times 0 squared plus 2, so that equals 2. So the coordinate of our, it's not actually going to be here, is it? It's going to be here. The coordinate of our stationary point is 0, 2. So our least value on this curve is 2, and our greatest value on this curve is 83. And that is that done.